Hi guys. So I am trying something a little different with my phone. I'm sorry, the screen's a little bit shaky. I'm trying to set up what's kind of like a Google camera or a document camera at my home computer because I want to walk you through the steps needed to draw the paths of the sun on this celestial sphere diagram. So when we're all done, it's going to have the three paths on it for summer, winter, and then the fall and spring path, which they share because, like we said in the notes, they're like BFFs. So we are going to start out with the, and hopefully you guys have, I'm going to give you access to this sheet. Ideally, if you want to walk through the steps to print it out and do it with me, going through the process is the best way to commit these kind of things to memory. If you're just watching, that's fine too, but you'll probably retain it better if you actually do it. So on your sheet of paper, we're going to write what latitude we live at. We're roughly 41.5 degrees north latitude, or you could say 41 degrees 30 minutes. But since we're going to be working with the angles, it's easier to not have it in minutes because we're not doing like anything on the map. We're doing it with degrees of the altitude of the sun. So in order to plot our fall and spring path, the equinox path, which is the one we're going to start at, I'm going to grab my calculator here. And actually, we'll write this on the paper too. Let me scooch this down a little bit so you could get the bottom of my paper on your screen. Let's just go like this. Doing it in pencil in case I make a mistake. It's a little bit lighter to see on the camera, but that's okay. All right, so we're going to start with the equinoxes, which again is fall and spring. So what we're going to do with our calculator is we're going to write 90 degrees, and then we're going to subtract from it our latitude, which is 41.5 degrees north, and then we're going to plug that in, see what we get. Kind of make this so you can see it, whatever angle will work best. So 90 minus 41.5 equals 48.5 degrees. So that altitude of the sun that's going to be our noontime sun. Oh, you know what we didn't do? Sorry. I haven't really showed you this graph very well. So on this little chart thing here, we have our observer. Our observer is standing on the ground. So all of this, you're welcome to shade this. I usually do it with a highlighter, but I'm going to do it with the pencil for now. This represents the ground. Okay. We are going to label the compass directions on this little sideways looking coin here. So we're going to make this one north. Right. We're going to make this south, opposite of north. This is just usually the perspective that you're given when we look at the celestial sphere diagram. And then I always kind of turn my head to the side so I can orient, north being up and south being down, which would make this direction east. Good. And then the last one we have left would be west. So what compass direction does the sun rise? In the east. So these are I'm going to put sun, rise, all along this line, anywhere along here where the sun might happen to rise on the eastern side. And then this whole horizon line will represent the sunset. So anytime the sun touches this solid black line is going to be a sunset. So back to where we were just a second ago, our equinoxes. So we took 90 degrees just because that's what we start with. A horrible pencil. Let's see, I got Ticonderoga here. It'll work a little bit better. Sorry, the table's a little bit shaky. So we start with our 90 degrees because that's what we start with. We're going to subtract from that our latitude, and it equals 48.5 degrees. So now I'm going to come over to here. I'm going to go up 45, 46, 47, 48 and a half is going to be here. I'm going to draw that noontime sun. I'm just going to label it here that it's noon. It's my noontime sun. Sorry, it's coming in and out of focus a little bit. And then we're going to bring our sun path down. So we know the sun rises due east in the spring and the fall. It rises exactly east. So this is going to be my sunrise. And I'm going to very slowly bring it up, 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 till I get to that 48.5. So any time along this line would represent an AM time, because this is sunrise is here, and then it's going to continue to get higher and higher and higher in the sky until it gets to noon. And then we're going to bring our sunset all the way down to due west, all the way down to there. So this is all our PM times. So 2 p.m. would be around here. 5 p.m. would be around here. Figuring if it's an equinox, the sun's going to set around 6 p.m. So that would be 6 p.m. This would be 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m., 12 a.m. I know that wasn't perfectly equally spaced, but that would be our sunrise and our sunset. So again, this is going to be everything for our equinoxes. So this is going to be spring. Am I on the screen? Yes, I am. Spring and fall equinox. Equinoxes, if we want to be grammatically correct there. So that would be March 20th is the spring one, and September 22nd would be the fall one, and those are all going to be at this spot right here. Now, in the notes, I told you guys that the Earth is tilted at, we just say 23.5 degrees. It's actually 23.4 degrees, so you could see where that's easy to round it to the halfway point. So the next one we're going to do here is going to be our winter one, and that axial tilt is going to come into play here. So for the winter path, what we're going to do is we're going to take the number we had here, 48.5 degrees. Remember how we got that. We're going to take our 48.5 degrees. Again, it's this number right here. And remember, the winter path is shorter. Sorry, my camera's moving like crazy. My dog's sitting on the table here and he keeps moving. So the winter path is going to be down here. Hold on, let me move him so that he doesn't, he's like itching himself. It's making the desk get all wobbly. Sorry. Okay. So the winter path is going to be down here. So this is going to be a lower number. So what we're going to do is we're going to take the number we had here and we're going to subtract from it the axis, the tilted axis. But we're just going to say that it's 23.5 degrees because that's an easier number to work with than 23.4. So we're going to subtract the two. So here we go. 48, let me see if you can see this, 0.5 minus 23.5 equals, and we got 25. So our noontime sun in the winter is going to be at 25 degrees in the sky. So, and then just I want to make a little side note here so you don't forget, where the heck did we get this number from? And this number is Earth's tilted axis. So now we're going to come over here. We're going to draw our winter noontime sun at 25 degrees. Remember, we got that number over here. So 25 degrees is here. This is our noontime sun. It's for our winter solstice. Remember, solstice means solstier, sol meaning sun, and sestier means to stand still. So the sun is going to stop when it gets down to this point and then make its way back up. We also said that oh, you know what? I forgot our month here. So this starts December 21st. Okay. So remember we said that the sun rises south of east in the winter. It rises at a point that is south of east. So that means somewhere here in the middle, this is going to be our sunrise, south of east. Remember we said birds migrate south in the winter. So this point is going to be south of east. I'm going to bring the noontime sun down here. So this is our AM path. And then it's still south because it's still winter. So our sunset is going to be south of west. So somewhere along this horizon line, we can label that this is the horizon. Somewhere along this horizon line, I usually just stick with somewhere in the middle, is going to be our setting sun in the wintertime at a point that is going to be south of west. So here we are south of west, and this is all of our PM times. Remember that this path only represents 9 hours of daylight. So this isn't going to be 6 o'clock. We could do the math to figure it out. I'm not sure off the top of my head exactly what time the sun would rise, but this would be noon. This would be 11 a.m., 10 a.m. This might be like 1 p.m., 2 p.m., 3 p.m., and so on. Remember, it's usually dark by 5 o'clock in the winter time. So that's our winter path. We've got our equinox path. And then now I want to focus on our last one, which would be our summer solstice. So we're going to go back to our little jump off point number here that we got up at the very beginning, our 48.5. And we're going to add to that, because if you think about it, our summer path should be up here somewhere. So we're going to add to it at our tilted axis, 23.5 degrees, just like before. I'm going to grab my calculator here. I'm going to go 48.5 plus 23.5, our axis tilt, and that's going to give me 72 degrees. And as you can imagine, if you lived at a different latitude, your whole celestial sphere would look a little bit different. Your numbers would be different based on the hemisphere you live in. It might be different. If you were at Santa's house, it might be different. So just things to take into consideration, but we tend to just focus on what's going on here in New York. So I'm going to go up to my 72 degree noontime sun. Just going to be up here. 72 is here. This is noon. This is going to be for the summer solstice, sun standing still. In the summer, our sun rises north of east. So remember, in the summer, the birds fly back north. They migrate back to the north. So summer is always going to be north of east, north of west. I'm going to bring this, there's my little point where the sun's going to rise. I'm going to go up, 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 up. This is all my AM times. And then it's going to set at a point that is north of my western point here. So this is just, it's weird, we don't really say northwest when we're talking about sunrise. We say north of west, north of east instead of northeast. Not a big deal if you said, northeast, northwest, but we just say it a little bit differently. And then this is going to be my PM sunrise. Notice this path is longer. This represents a 15-hour period of daylight here in New York. So this was 15 hours. This is 12 hours. This is 9 hours. If you want, we could even label that up here. 15, 12, and 9. Remember, each month we gain or lose an hour. So to touch on the fact that it's called summer solstice, which is, by the way, June 21st. It's the sun standing still. So if my pencil represents the sun's path, an average of the AM, PM one, this would be June. This would be July. So keeping your eye on that eraser, which is where our noontime sun would be. So this would be July, August, September. Let me angle that a little bit better. This is our September path. So then we would go down October, November, December, sun stands still. Now it ping pongs back up. After December comes January, February, March. We're at that path again. April, May, June, right? July, August, September, October, November, December, January, February, March, April, May, June. So we're just ping-ponging back and forth between these two paths throughout the year. So more direct sun rays in the summer and less direct sun rays in the winter. And then we've got, I want to just draw in here, this would represent the observer's shadow, would be pointing to the north. Because our noontime suns here in New York are always on what's called the southern meridian. This meridian is like a longitude line, right? It's a vertical line. So this noontime meridian is where our sun sits. It's always in the southern half of our sky. So whatever time of day it is, whether it's noon or whatever, our sun is always in that southern half of the sky. So that means an observer in New York, their shadow would always point north. Let's see, what else do I want to label on this? That might, oh, I have two more things I want to label. I was going to say, I thought that would be everything. This imaginary point directly overhead, you might remember from yesterday's lesson, is called zenith. In New York State, we never, ever, ever get the sun directly overhead. Our noontime sun will never be at zenith. The only place in the United States that will get the sun at zenith is Hawaii. The Big Island specifically will get the noontime sun on the first day of summer because they are on the Tropic of Cancer. Nowhere else in the United States will you get that noontime sun directly overhead. And then one last thing I want to point out, Polaris. Polaris is the North Star. For us, because we're at roughly 41 degrees north, our Polaris star will be in the northern half of the sky, also at 41 and a half to be exact, or as exact as we can be. So I'm going to put a little star here, and then I'm going to write that this is Polaris. So our axis is pointing up to that. Our axis, which is at Santa's house at the North Pole, has Polaris directly above it. So you kind of get an idea here of where the axis would be and where we view the sun's apparent path. So that is all for now. I hope that helps to clarify some stuff, and I will talk to you guys again soon.